Hi everyone, welcome to another episode of The Handy Philosopher. We're going to be looking at a reading by a philosopher named Karl Popper from his text Conjectures and Refutations. What we're going to be reading is actually a transcript of a lecture that he gave, so it's written in the first person I. Yeah, still some pretty intriguing stuff. Popper, this is sort of like a part two almost to the Kuhn reading that I did most recently. So those of you in my Year 11 class at the moment, we just finished talking about Thomas Kuhn and his view of scientific revolution. And the idea, I guess, important things to keep in mind for while we're reading Popper is that Kuhn firstly didn't think that science was moving towards truth. Remember, for Kuhn, a good scientific theory is not a truthful one, it's one that solves the problems that we have. And as long as it's doing that, the truth of the theory is really like irrelevant almost. And so, as long as a scientific theory solves problems, then it is worth holding on to as a scientific theory. Popper is going to be presenting a very different view. His view is going to be around what we should kind of like allow to be called science and what shouldn't be allowed to be called science. And we're really going to be focusing on a concept that he talks about a lot, which is called falsifiability or falsification. Okay. Look, I'll go through this obviously as we go through the reading, but in a basic sense, for a theory to be falsifiable, which is what Kuhn wants it, which is what Popper wants it to be, it needs to be able to make really risky predictions. In other words, it needs to predict things that are at least seem like they are unlikely to happen, and then when they do happen, then it's really like, whoa, okay, this guy really knows what he's talking about because no one else saw this coming. So hopefully that kind of makes sense. As I said, we'll go through it in a lot more detail, obviously, as we go through the reading. For those of you who are in my class, you can check on the OneNote or the TeamSpace about, to get a digital copy of the reading. If you can, print it out and annotate it as we go. Otherwise, yeah, just make sure you're following along with the digital copy and making your summary as always. So let's kick it off. Okay, so yeah, if you have it, get your reading out, pens and highlighters at the ready, and let's go. So we've got a very quick bit of background before we do start the reading. So, as I said before, did it again. Popper's main sort of purpose in this is to distinguish science from pseudoscience. So, pseudoscience, for those of you who don't know, are fake fields of science. Okay, so things that pretend to be scientific but actually are not. For anyone listening out there, if you're into astrology, that's a perfect example of pseudoscience. So it's something that presents as if it uses a scientific method, but it actually doesn't. And there's lots of reasons for that. And I look forward to some comments from astrology lovers. But Popper, he really wanted to go on this mission of like, well, why should we give certain theories and certain fields of study more weight than others? Like, why should we trust one thing like science more than we should trust something else, like, fantasy, like astrology or palm reading or fortune telling, any of that kind of stuff? Okay, so why should we draw a line between these two? Or not so much why, but how. How do we draw a line between these two? And Popper, as it says there, identified falsifiability as a key element that makes a scientific theory. Okay, and this idea of falsifiability means that for a theory to be considered scientific, it needs to be making predictions that could be wrong. Okay, not that are necessarily wrong, but actually could be wrong. And in this way, the prediction needs to be very restrictive, as you can see down the bottom point there. So it really can only be one possible result that can happen, and everything else is impossible. I've written a little example there. It's not a perfect example, but I predict that when I drop my pen from my hand, assuming that there's no other forces like wind or anything like that, but I predict when I drop my a pen from my hand, it will fall towards the center of the earth. In this way, if it falls any other way, then my theory is incorrect. So it's a very restrictive prediction. If I had just said, when I let go of my pen, it will move. Well, any movement then fits with my theory. There's actually nothing that could happen apart from the pen staying perfectly still, I guess, that would disprove my theory, but it just allows for too much to happen. Okay, so good science, according to Popper, is restrictive science. It only allows for certain things to occur. So let's get started with the reading. There's a couple of quotes on this first page. On the left side there, a little quote there from Einstein. There could be no fairer destiny for any theory than that it should point the way to a more comprehensive theory in which it lives on as a limiting case. So Einstein here basically saying what Popper is talking about, which is that the great destiny of science is to be of scientific theory is to be overthrown by something that explains things more clearly or more elegantly. And then Mr. Turnbull had predicted evil consequences and was now doing the best in his power to bring about the verification of his own prophecies. This one particularly is linked to what Popper is going to be talking about in our reading. It's talking about this character, Mr. Turnbull, had predicted evil consequences, and he was then going about making sure that there were evil consequences. So in other words, he was doing things to confirm his own worldview. Okay, it's a little bit like, if you really think about something like social media, okay, the wizards at Facebook and whatever, using all of your online behavior, they know what you like and what you don't, and so they will fill your feed with things that you like instead of things that you don't. And in this way, all that you're ever getting is confirmation that the way you see the world is the correct way. Okay, you're not actually getting a fair and balanced look at things. You're just getting things that confirm your worldview. And this is the danger that Popper thought science sort of flirted with, and what made science drift into pseudoscience when all it ever did was look for things that supported it. We're going to use a couple of examples to explain this as we go, but we might start the actual reading. Okay, so when I received the list of participants in this course and realized that I had been asked to speak to philosophical colleagues, I thought, after some hesitation and consultation, that you would probably prefer me to speak about those problems which interest me most, and about those developments with which I am most intimately acquainted. I therefore decided to do what I have never done before, and to give you a report on my own work in the philosophy of science since the autumn of 1919, when I first began to grapple with the problem, when should a theory be ranked as scientific? Or is there a criterion for the scientific character or status of a theory? So remember, this is actually from a lecture that Popper gave, which is why it kind of reads a little bit strangely. You have to imagine him standing in front of you talking while we're going through this. But those are the key questions that he's going to be looking at. When should a theory be ranked as scientific, and is there a criterion for the scientific character or status of a theory? So in other words, can I take something and figure out, is this science or not? Okay. The problem which troubled me at the time was neither when is a theory true nor when is a theory acceptable. My problem was different. I wished to distinguish between science and pseudoscience, knowing very well that science often errs and that pseudoscience may happen to stumble on the truth. So this is an interesting thing here. Popper is trying to draw this line of separation between science and pseudoscience. And that sounds very easy, but when we keep in mind that scientists and science as a field makes mistakes, and that sometimes fortune tellers predict the correct thing, and astrologers predict the correct thing, we can't just we can't be simplistic and say that, well, science will be right and pseudoscience will be wrong, um, because that won't always be true. So it's not just the end result that matters. What Pop is going to be talking about is it's the method that you use to reach that end result. That's what really separates science from pseudoscience. Okay. I knew, of course, the most widely accepted answer to my problem, that science is distinguished from pseudoscience or from metaphysics by its empirical method, which is essentially inductive, proceeding from observation or experiment. So this, in class we've talked about the scientific method of, prediction, observation or experiment, reporting results, repeating, basically. So that's what he's talking about here. But this did not satisfy me. On the contrary, I often formulated my problem as one of distinguishing between a genuinely empirical method and a non-empirical or even a pseudo-empirical method. That is to say, a method which, although it appeals to observation and experiment, nevertheless does not come up to scientific standards. He's talking here about those fields that pretend to use the scientific method but actually don't. Okay, how do we draw the line between the ones who are actually using the empirical method correctly and the ones who aren't? The latter method may be exemplified by astrology, with its stupendous mass of empirical evidence based on observation, on horoscopes, and on biographies. So here, Popper's referencing astrology. He won't do this for very long because, as he points out, he'll talk about theories that he knows more about and are more closely linked to science. There's not many people who genuinely view astrology to be within the realm of science or as reliable as science. And look, I don't want to badmouth people too much, but the people who do clearly don't actually understand how science works. But what astrology does is it uses a pseudo empirical method. So it looks like it's actually using the scientific method when it comes up with things like, you ask an astrologist to predict what's going to happen to you next month, and they have to make observations. They have to look at the stars and I don't know, whatever they do, like say whether Jupiter's ascending in your quadrant of peace, or I don't know, whatever rubbish astrologers come up with. But it looks scientific. They're not just going, oh, whatever. Like they actually look at things and then they make their prediction, much like a scientist does. So how do we separate between these different fields? Okay, so this is really what Popper was trying to do. Okay, but as it was not the example of astrology which led me to my problem, I should perhaps briefly describe the atmosphere in which my problem arose and the examples by which it was stimulated. After the collapse of the Austrian Empire, this is after World War I, there had been a revolution in Austria. The air was full of revolutionary slogans and ideas and new and often wild theories. Among the theories which interested me, Einstein's theory of relativity was no doubt by far the most important. Three others were Marx's theory of history, Freud's theory of psychoanalysis, and Alfred Adler's so-called individual psychology. Okay, and I'll just change the slides over here because I've got these down as examples that Popper talks about. Okay, so he's going to focus his discussion for the next little while on these three theories. Okay, and what he's going to show is that Marx's view of history, Freud's psychoanalysis, and Adler's individual psychology are examples of pseudoscience. And he's going to explain the reason for this. Particularly, he's going to talk about the fact that, well, in these, any evidence that popped up could be accepted within the theories. Okay, and like I said, we'll explain this as we go and we do a bit more reading. And he's going to use Einstein's theory of relativity as an example of a scientific theory. Okay, so it's not like Marx, Freud, or Adler's theories. Okay. There was a lot of popular nonsense talked about these theories, and especially about relativity, as still happens even today. But I was fortunate in those who introduced me to the study of this theory. We all, the small circle of students to which I belonged, were thrilled with the results of Eddington's eclipse observation, which in 1919 brought the first important confirmation of Einstein's theory of gravitation. It was a great experience for us, and one which had a lasting influence on my intellectual development. So, just a quick outline of what Popper's talking about here. So, for those of you who aren't familiar with Einstein's theory of relativity, and look, I'll preface this by saying that I am certainly no physicist, so I'm going to be giving a very, very basic explanation of it. But Einstein's theory of relativity was that light is impacted by gravity. Okay, so in other words, just like gravity attracts, the gravitational pull attracts anything like any particles or anything like that, like it pulls it in. Uh, Before Einstein's theory of relativity, the view of light was that light was a different thing. Light was a wave, okay, not a particle. And so the theory was that light would not be impacted by gravity. In other words, light wouldn't be attracted to things with a large mass in the same way that particles are attracted to things with a large mass. They get drawn in. Okay, this is what pulls your pen towards the center of the earth when you drop it. It's the gravitational pull of the earth acting on the particles within the pen. Okay, same reason you don't float up to the sky when you're walking around. Einstein's theory was that light actually would be affected by gravity. And this was like, people thought that this was ridiculous in the scientific world for a very long time. Now, what's interesting is Einstein said, he predicted that the placement of the stars in the sky would actually be different during the day than they would be at night. Okay, even though, so just to be clear, like when you look out your window now, if it's assuming you're listening to this during the daytime, there are stars up in the sky just like there are at nighttime. It's just that the light from the sun is so bright that it washes out the light from those stars. Okay, because obviously we're over the other side, so the light from the stars is coming past the sun before it gets to Earth. Whereas when it's nighttime, if you think of the Earth going around the sun, the light from the stars hits Earth before it then hits the sun. Okay, hopefully that's making sense to you. So what's interesting is that Einstein said, well, during the day, the placement of the stars in the night sky would actually be different, because as the light from those stars goes past the sun has such a strong gravitational pull that it will actually bend the light. Okay, the light from these stars in the sky going past the sun would be bent, and so when they end up being projected onto the Earth's atmosphere, they'll be in a different position because they kind of got pulled by the gravitational pull of the sun. Everyone thought this was ridiculous. It just so happened that in 1919, Eddington observed an eclipse and was able to then create a star chart from that. And it showed that actually Einstein was correct. The stars in the sky were in a different position during the day than they were during the night. And not only were they correct, like Einstein, the position of the stars was correct. Not only was it different, it was actually what Einstein predicted. They were where Einstein predicted they would be. So this was huge because this was the first time that we had actual hard scientific observation to show that Einstein's theory of relativity was correct. Okay, so really, really, really big event. If you don't understand the science at all, that's fine. I'm sure I don't as well. But the takeaway here is that Einstein's theory had made a really risky prediction. No one else in the scientific world was saying that the light from the stars would be affected by gravity, okay, or the light from anything would be affected by gravity. Okay, no one had said that. Einstein made that prediction. Everyone thought it was rubbish. He made a very risky prediction. And what he was able to, well, what Eddington showed through the eclipse observation is that Einstein's prediction was actually correct. And the other theories, therefore, were wrong because they said that that would be impossible for the light from the stars to be impacted by the gravity of the sun. Okay, so where were we? My intellectual development. The three other theories I've mentioned were also widely discussed among students at that time. I myself happened to come into personal contact with Alfred Adler, and even to cooperate with him in his social work among the children and young people in the working class district of Vienna, where he had established social guidance clinics. So this is very interesting. Karl Popper actually worked with/for the famous psychologist Alfred Adler. It was during the summer of 1919 that I began to feel more and more dissatisfied with these three theories: the Marxist theory of history, psychoanalysis, and individual psychology. Excuse me. And I began to feel dubious about their claims to scientific status. So Popper here is really starting to think that these three theories, Marxist theory of history, psychoanalysis, and individual psychology, aren't real science. My problem, perhaps, first took the simple form. What is wrong with Marxism, psychoanalysis, and individual psychology? Why are they so different from physical theories, from Newton's theory, and especially from the theory of relativity, Einstein's theory? So he's really asking himself the question here, well, what's the difference between these two? To make this contrast clear, I should explain that few of us at the time would have said that we believed in the truth of Einstein's theory of gravitation. This shows that it was not my doubting the truth of those other three theories which bothered me, but something else. Yet neither was it that I merely felt mathematical physics to be more exact than the sociological and psychological type of theory. Thus, what worried me was neither the problem of truth at that stage at least, nor the problem of exactness or measurability. It was rather that I felt that these other three theories, though posing as sciences, had in fact more in common with primitive myths than with science, that they resembled astrology rather than astronomy. Okay, so astrology is looking at the stars and saying, oh, you're a Virgo, you're gonna, face challenges this month. Astronomy is the study of the stars. So that's the science side. So it's just to be clear, Popper's saying it's not a problem of the measurability. So it's not that physics is just far more measurable than something like psychology is. Okay, because you're talking about like mathematical principles in physics, which are very, very measurable. They're either right or wrong kind of thing. Whereas in psychology, when we're talking about like human behavior, this is a very difficult thing to be exact about. So it's not that, okay? And it's not, and Popper's saying it's not just that he thought that the theory of relativity was true and the others were false. He actually didn't necessarily believe the truth of relativity at that time either. So he was skeptical about all of these theories. So what was it then that that made Einstein's theory seem more scientific to Popper than these other theories? Okay. So I found that those of my friends who were admirers of Marx, Freud, and Adler were impressed by the number of points common to these theories, and especially by their apparent explanatory power. So this is an important concept for Popper, explanatory power. What he's talking about here is the ability of a theory to explain a phenomenon. Okay, so I can explain your behavior using Freud's theory of psychoanalysis. That's what Popper's talking about here. I can explain history based on Marx's view of history. Okay, so explanatory power. Can they actually explain or give us a solution to the problem that we're looking at? These theories appeared to be able to explain practically everything that happened within the fields to which they referred. The study of any of them seemed to have the effect of an intellectual conversion or revelation. opening your eyes to a new truth hidden from those not yet initiated. So it was kind of like once you adopted these theories, you saw the entire world a different way, and other people didn't understand because they didn't know the theory yet. But once they did it was like joining a cult, suddenly the whole world looked different. Okay. Um, Once your eyes were thus opened, you saw confirming instances everywhere. So you saw things that proved your theory right everywhere. The world was full of verifications of this theory, so things that proved it right. Whatever happened always confirmed it. Thus, its truth appeared manifest, and unbelievers were clearly people who did not want to see the manifest truth, who refused to see it, either because it was against their class interest or because of the repressions which were still unanalyzed and crying out for treatment. The most characteristic element in this situation seemed to me the incessant stream of confirmations of which verified the theories in question, and this point was constantly emphasized by their adherents. So this was the first thing that started to worry Popper a little bit, that the followers of any of these three theories, okay, Marxism, Freud's psychoanalysis, Adler's individual psychology, they could find supporting evidence anywhere, okay, anywhere. And so, Popper was a bit like worried about this. This didn't seem right to him, okay. Uh, So, a Marxist could not open a newspaper without finding on every page confirming evidence for his interpretation of history, not only in the news, but also in its presentation, which revealed the class bias of the paper, and especially, of course, in what the paper did not say. So Marxism, look, we won't talk about it too much because it's not really a scientific theory in any way, and isn't really considered one. Freud and Adler, though, kind of are, which is worrying. But Marxist's view of history is that basically what we're told is never the truth. It's always through some sort of interpretation, which seems very obvious, like as you say it, but it's a very extreme view of this in terms of almost like a puppet master idea of like, and this is why the world is the way that it is because we never get the truth, and so you're being controlled, and etc. etc. Very alarmist. Sorry for those of you who are Marxists. I don't mean to be dismissive, but that's kind of the view. And Popper here is using it as an example, and he's saying that someone who was a Marxist couldn't help but find evidence of it being correct. Like every time they opened the newspaper, it was just filled with the type of bias that's present or suggested in Marxism, the repression of the working class or whatever we're talking about, in this way, Marxism, of course, had to be right. It couldn't possibly be wrong. Okay. The Freudian analysts emphasized that their theories were constantly verified by their clinical observations. So Freud worked one-on-one with patients, as did his followers. So that's what they mean by clinical observations. As for Adler, I was much impressed by a personal experience. Once in 1919, I reported to him a case which to me did not seem particularly Adlerian, but which he found no difficulty in analyzing in terms of his theory of inferiority feelings, although he had not even seen the child. So Popper took an example that he had gotten from a child that he had worked with at one of Adler's clinics, because he didn't think that what the child was reporting could fit into Adler's theory, but Adler had no problem fitting it into his theory. Okay. And Adler didn't even need to speak to the child to do it. That's how easily he fit the child's story into his theory. Slightly shocked, I asked him how he could be so sure. Because of my thousand-fold experience, he replied, whereupon I could not help saying, And with this new case, I suppose your experience has become 1,001-fold. You can imagine, like, in like a dusty old lecture theatre, all of these intellectuals sort of chuckling at Popper's little joke there. So basically, Alfred Adler said to him, "Well, I've just got so much experience in talking to people that I understand how my theory fits with everything." And Popper kind of smart-ass replies saying, and now you've got even more experience, don't you? When obviously Adler hadn't spoken to the child at all. The poor joke is not important at all. But what is important is what we understand from this. So what Popper is really worried about is the fact that everywhere that these people turned, they could only ever find evidence that supported their theory. Okay, and in fact, it started to look impossible for there to be evidence that didn't support their theory. Okay, we'll continue on. What I had in mind was that his previous observations may not have been much sounder than this new one. So Popper was a little bit worried by this because here Adler was saying, oh yeah, the child's behavior is explained by blah, blah, blah. And it got Popper thinking, well, what if he just did this with every patient? What if he basically just made up the answer and said, oh, it's because of this, interpreted it in his own way to make it fit with his theory. Okay. Sorry, I'll start that paragraph again. What I had in mind was that his previous observations, this is Adler he's talking about, may not have been much sounder than this new one, that each in its turn had been interpreted in the light of previous experience, and at the same time counted as additional confirmation. What I asked myself, did it confirm? No more than that a case could be interpreted in light of a case could be interpreted in the light of the theory. But this meant very little, I reflected, since every conceivable case could be interpreted in the light of Adler's theory or equally of Freud's. Okay, so I just want to pause here for a second to talk about Adler and Freud. These two very famous psychologists presented some of the first theories about essentially why people behave the way that they do. Now, both of them presented different ideas around notions that, like, we have to progress through certain crises to then, and that then develops our character as we grow. And depending on how well or poorly we go through these different crises, will determine what type of character we develop. Okay, seems relatively straightforward, but Adler and Freud both came to very different conclusions about what sort of crises we face and what sort of person that would create. Now, what's interesting is that these two theories should have been exclusive of each other. In other words, evidence that supported Freud should have disproved Adler. Okay, it should have worked that way, but it didn't. Anything that supported Freud's theory would also support Adler's. Okay, an Adlerian, someone who followed Adler's theory, would be able to accept the evidence just as easily as a Freudian would, someone who supported Freud. Okay, we'll get an example of this here. So I may illustrate this by two very different examples of human behavior. That of a man who pushes a child into the water with the intention of drowning it, and that of a man who sacrifices his life in an attempt to save the child. Each of these two cases can be explained with equal ease in Freudian and Adlerian terms. So we're talking about imagine one man pushing a child into a lake to drown it, another man jumping into a lake to save a drowning child. Okay, two very different behaviors, but Freud and Adler would have zero issue with explaining why these happened. Okay, so to start off with, according to Freud, the first man suffered from repression, let's say of some component of his Oedipus complex. I won't go into it now, but the Oedipal complex is basically that boys want to have sex with their mums and they're really worried that their dads are going to cut their penises off. I'm really not making this up, kids. Okay, but according to Freud, the first man suffered from repression, say of some component of his Oedipus complex, while the second man had achieved sublimation. According to Adler, the first man suffered from feelings of inferiority, producing perhaps the need to prove to himself that he dared to commit some crime. And so did the second man, whose need was to prove himself that he dared to rescue the child. I could not think of any human behavior that could not be interpreted in terms of either theory. It was precisely this fact, that they always fitted, that they were always confirmed, which in the eyes of their admirers constituted the strongest argument in favour of these theories. It began to dawn on me that this apparent strength was in fact their weakness. Okay, so just to pause for a moment, I want to explain this a little bit more clearly. I'll give an explanation of how one of these theories would be making a scientific prediction, according to Popper. I want you to, so Freud's Oedipus complex, so this is a childhood, a developmental theory, where a child is sort of, particularly male childs for Oedipal complex. Girls, you get one too. It's called the Electra complex. So a male child begins to want to assert himself in the family unit. Obviously, being a child cannot possibly overpower their father. And so the sort of the developmental issue is, well, how does the child develop a sense of themselves when they feel repressed by their father all of the time? They can't become the man they want to be because their father is the man that they want to be, and they would have to overthrow their father to become that. Freud argued that this is something that all boys go through. And like I said, girls, you have a version of this too. But for this to be a scientific theory, what we should really have is a very, very specific prediction. So if a child does not progress through this developmental stage correctly, it will result in this sort of behavior. So a child who does not progress through it becomes a murderer, for example, whereas a child who does progress through it becomes a well-rounded individual. But Freud's theory doesn't give this. Okay, there's 1,000,001 things that issues with the Oedipal complex could result in someone's adult life. Okay, there is no one thing. And so in this way, anything could fit with Freud's theory. Okay, why does someone want to drown a child? Oh, it's because of their Oedipal complex. They want to exert themselves as a man, and they do this by, killing. This is the most manly thing that they can do, but they kill in a way to make sure that they are never at risk because they always fear being caught by their fathers. Okay, so this is why they kill the child, because there's no chance of the child fighting back. Compared with, why does someone go and save the child? Well, we could say, it's because they failed to progress through their Oedipal complex, and now they've got this hero thing. They want to prove themselves as a man, prove themselves to the world and to their fathers that they're a real man, and so they're looking for these times to become these heroes and say, see, I'm a real man, I can do these things. Anything that we do can fall into this. And this, for Popper, is the problem. Okay, there's no evidence that we can discount. Okay, there's nothing that we can say, well, if this happens, then the theory is wrong. Okay, any type of adult behavior can fit into Freud's theory, as well as Adler's for that matter. And so this is the problem. This is actually their weakness. Let's continue. With Einstein's theory, the situation was strikingly different. Take one typical instance, Einstein's prediction, just then confirmed by the findings of Edington's expedition. Einstein's gravitational theory had led to the result that light must be attracted by heavy bodies, such as the sun, precisely as material bodies were attracted. So this is what I was talking about before, that light is impacted by gravity in the same way that particles are. As a consequence, it could be calculated that light from a distant fixed star whose apparent position was close to the sun would reach the Earth from such a direction that the star would seem to be slightly shifted away from the sun. Or, in other words, that stars close to the sun would look as if they had moved a little away from the sun and from one another. This is a thing which cannot normally be observed, since such stars are rendered invisible in daytime by the sun's overwhelming brightness. But during an eclipse, it is possible to take photographs of them. If the same constellation is photographed at night, one can measure the distances on the two photographs and check the predicted effect. So this is the Edingtons experiment. Taking a photo of the stars at night, taking a photo of the same section of sky during the day during an eclipse, so you actually get to see the stars, and calculating the difference in their position. Traditional science before Einstein predicted that there would be no difference. The constellations would appear exactly the same. What actually happened was there was as Einstein predicted, there was a difference. But this was a very specific prediction. Had the stars appeared in the sky in the same position during the day than they do at night, then Einstein would have been wrong. It would be impossible to say Einstein's theory is still right and the stars appear in the sky in the same position. Impossible. Okay, now think back to what I just talked about with Freud's theory. Anything can fit his theory. There is nothing that's impossible. Whereas Einstein's theory was very specific. Okay, the predictions he made were very risky in terms of there was only one way for him to be right and lots of ways for him to be wrong. It just so turned out that he was right. Okay. Now, the impressive thing about this case is the risk involved in a prediction of this kind. If observation shows that the predicted effect is definitely absent, then the theory is simply refuted. Okay, so in science, if I make a prediction and it's not the case, then I'm wrong. It's as simple as that. We say that the theory is refuted. It's proven wrong. The theory is incompatible with certain possible results of observation. In fact, with results which everybody before Einstein would have expected. This is quite different from the situation I've previously described, when it turned out that the theories in question were compatible with the most divergent human behavior, so that it was practically impossible to describe any human behavior that might not be claimed to be a verification of these theories. Now, Popper's not here talking about a adolescent book series. He's talking about the problem of the other theories. With Einstein's, it was very specific. The prediction it made was very specific. It could only be right in a very, very specific way. Whereas any behavior, any human behavior would support Freud or Adler's theory. Okay, and so this, in essence, is the problem. Okay, these considerations led me in the winter of 1919-1920 to conclusions which I may now reformulate as follows, and I'll just change the slide. I've summarized the conclusions here just very briefly, but let's have a look at them in some more detail. Number one, it is easy to obtain confirmations or verifications for nearly every theory if we look for confirmations. Okay. If you yourself or other people that you know do believe in things like astrology or palm reading or fortune telling or whatever we're talking about, any pseudoscientific pursuit, what you'll often find is they really go out of their way to identify confirmations. So think of astrology as our example. When I read, my astrological prediction in the paper for that day, I'm Cancerian, and so I will face challenges today. Okay, what does that mean? All right. And so if I believe in astrology, what I'm going to do is I'm going to go out into the world and I'm going to be looking for things that confirm that prediction, that say, yeah, that's right, this person can predict my future. Okay, so when I'm struggling to get the the lid off the jam jar, oh my God, I'm facing a challenge today. See, astrology's right. And when I step out onto the road, not looking where I'm going, get hit by a car, I'm like, oh, see, astrology's right. I'm facing challenges now. Like anything. If you're looking for evidence that's going to support something, uh, you'll find it. Okay. And what's often going to happen is you're going to interpret things specifically so that they do confirm your theory. Um, Number two, confirmations should count only if they are the result of risky predictions. Um, uh, that is to say, if unenlightened by the theory in question, we should have expected an event which was incompatible with the theory, an event which would have refuted the theory. So he's specifically referring to Einstein's theory here, but basically, when can if I make a prediction and it turns out to be right, when can I count that? Well, Popper's saying when it was a risky prediction. So let's use astrology as our example again. Instead of making a very non-risky prediction, like you're going to face challenges today, which, as I pointed out before, anything from struggling to get the lid off a jar to being hit by a car would fit with that. It would be impossible, basically. Even if you didn't get out of bed that day, you could say, well, I faced the challenge of getting out of bed. I just couldn't get out of bed. That was my challenge that day. So anything can confirm it, right? Let's think of what astrology would have to do for its confirmation to actually count. They would have to say, instead of you would face challenges at this day, I would have to open the paper. I'd have to look at my astrological sign, which I said before is Cancer, and I'd have to see something along the lines of, at 11:15 this morning, you will step out your door and you will walk towards the road. You will fail to look both ways because you were distracted by a message that popped up on your phone. You'll then be hit by a car. The license plate of that car will be this. This will be the make and model. That's how specific and risky that prediction is. That prediction would have to be for it to count. Okay, that's how specific. If I get hit by that same car at 11:20 instead of 11:15, it doesn't count. If I get hit by another car at 11:15, not the one that's specifically listed there, it doesn't count. If I get hit by the car at 11:15, but it's not because I'm distracted because of a message on my phone, it doesn't count. So confirming evidence only counts when it's a really, really, really risky prediction. Okay. Think of Einstein's example. Everyone thought that it was crazy for light to be affected by gravity. And with Eddington's observation, his specific prediction turned out to be right. Okay, when everyone thought it would be wrong. This is a risky prediction. Okay. Number three, every good scientific theory is a prohibition. It forbids certain things to happen. The more a theory forbids, the better it is. Okay, so think back to those two predictions: that you'll face challenges versus you'll be hit by a car at 11:15. One of them allows for anything to happen. Okay, so it doesn't forbid anything. Like I said, staying in bed that day, being hit by a car, not being able to get the the lid off a jar of jam. All of these things are challenges. Okay, compare that to you'll be hit by this specific car at 11:15 because you're distracted from a message on your phone. All right, that is very restrictive. Very, very restrictive. It forbids a whole bunch of stuff. Like I said before, if it's a different car, it doesn't count. So it forbids any other car, any other time, any other reason for my distraction. All of that is forbidden by the theory. Okay. Number four, a theory which is not refutable by any conceivable event is non-scientific. Irrefutability is not a virtue of a theory, as people often think, but a vice. So it's a real weakness in a theory when it can't possibly be proven wrong. Einstein's theory can be proven wrong. Okay, it just wasn't. With Edington's, experiment, had the stars appeared in their normal location, then Einstein would be wrong. But they weren't. Had they appeared in a location different to what Einstein had predicted, then Einstein would be wrong. But they weren't. They were where Einstein predicted them to be. In this way, having a theory that you can't possibly prove wrong is not actually good. It's bad. Okay, because a theory that can't possibly be proven wrong is a theory that's impossible to test, which means it's not a scientific theory. Because by definition, a scientific theory is a testable theory. Number 5, every genuine test of a theory is an attempt to falsify it or to refute it. Testability is falsifiability, but there are degrees of testability. Some theories are more testable, more exposed to refutation than others. They take, as it were, greater risks. So when we test a theory, when we use the scientific method, then what we're actually trying to do is prove a theory wrong. I want you to imagine that your enemy is trying to undermine you. Wouldn't they figure out lots of different ways to try and do that? Okay, that's basically what science should be. When you use the scientific method, you should be looking to prove a theory wrong, not to prove it right. Okay, in this way, you're going to come up with really, really strict experiments and observations. And when that theory survives that, hey presto, look at that, you've got a really strong theory. Anyone who's seen the sort of quasi-documentary Beyond the Curve, it was available on Netflix. I hope it still is. It's well worth a watch. But it's about flat earthers. Right at the end, spoiler alert, mute now if you don't want to know, but they talk right at the end. They show these flat earthers running experiments to show that the Earth is flat. Okay, what they're really trying to do is prove that the Earth is not round, and their experiments fail. So they prove that the Earth is round, quite hilariously. And so in this way, that's the way that you need to think about it. Think of someone who disagrees with the theory. What sort of experiment would they create for you to pass? If you haven't been able to tell from the moment, I think from what I've said so far, I think astrology is just rubbish. It's hocus pocus crap that is used to very successfully pry money out of people's wallets. That's it. Okay, there is no great destiny written in the stars, according to my perspective, at least. And so I'll come up. I am an enemy, for lack of a better term, of astrology. So I'll come up with a experiment for astrology. When an astrologist can make a specific prediction about my future behavior, as specific as the one that I've given in the example, like at 11:15, I'll be hit by this car with this license plate because of being distracted by a message on my phone. When astrology can do that, then I'll treat it with more respect. Okay, until it can, then no. Once it can pass a prediction like that, then I'll give it some time of day, but not until then. Okay. Number 6, confirming evidence should not count except when it is the result of a genuine test to the theory, and this means that it can be presented as a serious but unsuccessful attempt to falsify the theory. I now speak in such cases of corroborating evidence. So when can we say that, I ran an experiment, it showed that the theory was right? You can do that when you were actually trying to prove the theory wrong, is what Popper is saying here. In other words, when it's a really genuine test. It's not done by someone who has a vested interest. It's not done by lovers of the theory who just want to see it right. It's done using the actual proper scientific method with skepticism and being open to the idea that this theory may be wrong. Okay. Number 7, some genuinely testable theories, when found to be false, are still upheld by their admirers. Now, when we're comparing to Kuhn, this is a particularly important point. Okay. For example, by introducing ad hoc some auxiliary assumptions. So ad hoc after the fact. So imagine I run an experiment the experiment doesn't go as I want it to, but I don't want to discard my theory. So I go back and change my theory, and now my theory fits with the results of the experiment, whereas it didn't before. I make adjustments. Okay. Or by reinterpreting the theory ad hoc after the fact in such a way that it escapes refutation. Such a procedure is always possible, but it rescues the theory from refutation only at the price of destroying or at least lowering its scientific status. So every time we tweak a scientific theory to fit with evidence that did disprove it, we weaken that scientific theory. I later described such a rescuing operation as a conventionalist twist or a conventionalist stratagem. One can sum up all this by saying that the criterion of the scientific status of a theory is its falsifiability or refutability or testability. So we need to be able to run very strict tests on science, and it has to be possible for those tests to prove that theory wrong. If it doesn't, that's okay, like with Einstein's theory, okay, and the Eddington observation. It's okay that when it's not proven wrong, that's fine, but there has to be the possibility of it being proven wrong. If it's not possible to be proven wrong, then it's not a good theory, okay? All right, we'll leave it there. It's a long recording, I know, so thank you for sticking with it, but hopefully it's made sense. For those of you who I'm teaching, I'll speak to you on Microsoft Teams later on. But yeah, have a great day, everyone. Wash your hands during this coronavirus stuff. Let's get through this together. Stay home, stay healthy. All right, have a great day, everyone. Bye.